Hey guys, so today we're going to talk about what you can expect from Algebra 1 as well as the first lesson. So when you open up your Algebra 1 on Schoology, this is what you see. Something sort of like this. Yours may look a little bit different because this is the teacher version. So when you scroll down, you will see two folders. Week of 824 through 828 for digital learners, and the week of 824, 828 for in-person learners. So you are a digital learner, you're going to click on the digital learners, and when you click on it, you will see each individual day. So we're going to do the notes for Tuesday. So click on your relation function, domain, and range notes, and this is what pops up. Okay. So let's get into the lesson. Relations. Relations are a connection between two things that are represented by numbers. Think about it as like a sort of ordered pairs. Ordered pairs do show relationships. So you have an X and you have a Y. Okay? In an ordered pair, X is your input, and this is what we call the domain. Y is your output, or what we call the range. And we'll learn a little bit later that sometimes that can be represented by f of x. So there are 6 common ways to represent a function and a relation. We've already talked about one being ordered pairs, an x and a y. Then we have what we call mapping. Now, mapping is... Okay. Mapping is when you have your set right here. So mapping is when we have a set of x values, -1, 3, and 8, and a set of y values, 6, 2, and 3. And it shows you which one, just like we had an ordered pair, the x and the y, are mapped together. So 3 is connected to 6, -1 is connected to 2, and 8 is connected to 3. We can also see these in a table. So a table of x and y values. When the x is 3, the y is 6. When the x is -1, the y is 2. When the x is 8, the y is 3. So all 3 of these represent a relation. Here's 3 more ways. We can also do it by graphing. So the same 3 points that we've been talking about, we could graph -1, 3, 3, 6, and 8, 3. So lines and curves are just a whole bunch of ordered pairs together. We have word problems. That's one way we represent them, as well as an equation. So y equals x plus 1. So let's look at this set of ordered pairs. 2, 4, 1, -2, 3, 0, -2, 4, and -1, 2. Our domain, input, or x values are 2, 1, 3, -2, and -1. Our range, y values, also known as your output, is 4, -2, 0, 4, and 2. Notice how we have the number 4 twice in the range. When we actually write it down, we only have to write it once. We can represent the same relation in mapping, a table, or a graph. So a domain or range can be an inequality, which means it just includes every x value that's greater than or less than, or every y value that's greater than or less than a specific number. So for this example, if you look at your domain, which is on the x-axis, you're going to read from left to right. What is the leftmost number that this line includes? -4. What is the rightmost number that this line includes? Well, it goes to infinity because it's a line. It's going to go all the way up. The range are your y's, so you're looking at the y-axis. What is your bottommost number? -1. What is the topmost number? Infinity. It's going up forever. So it includes all the values that are between there. Let's look at this one. Find the domain and range of the graph. So the domain being your x values, what is this picture in between on the x-axis? Well, it's between -3 and 1. So our inequality shows us that x is in between -3 and 1. What are your y values? So where does it start on the y-axis? And where does it go to? On the y-axis, the topmost is 0. The bottommost is -4. So it would be between 0 and -4. Don't look at that. That was a typo. So functions. Don't forget this. A relation is where every input value has only one output value. All functions are relations, but not all relations are functions. Relations are ordered pairs. So functions can be linear or nonlinear. Let's look at these examples. Is this a function? Well, 1, 2, and 3. 1 is mapped to only 1, 2 is mapped to only 2, 3 is mapped to only 1. Yes, it's a function. Let's look at this one. 1, 3, 1. 1 is mapped to 3, 3 is mapped to 4, and 1 is also mapped to 2. So 1 is mapped to 2 different numbers. So no, it's not a function. The third one. 1, 2, 3. 1 is mapped to 2, 2 is mapped to 3, 3 is mapped to 4. Yes, it is a function. You can also use a thing called a vertical line test. So if you imagine your finger going across the axis, the x-axis, sliding vertically along your page, or your pencil, lay your pencil down, slide your pencil vertically along your page. If the line or the dots only hit the pencil once, then it's a function. If they hit it more than once, it's not a function. So let's look at number 1. If we laid a pencil down and slid it across the page, would it hit any dot, any part of this relationship more than once? No, it is a function. Every x has one y. But on number 2, notice if we laid our pencil down, it would hit all of those points. So it's not a function. The vertical line test is an eye test to see if a graph is a function or not. If you take a vertical line and move it from left to right, it will show you if a graph function has more than one output for each input. If there's more than one point that touches on that vertical line at the same time, then it's not going to be a function. So let's look at these. If we took our pencil and laid it down, number 1, yes, it's a function. Number 2, no, it's not a function. Number 3, it would hit here, it would hit here and here. So no, it's not a function. Number 4, yes, it is a function. Function or not? Why is this one not a function? Well, because 1 goes to 4 and 5. It has more than one output, so it's not a function. Number 2, in the table above, what missing value would make it a function? Well, any number that's not -3, 3, 8, or 0. Well, it could be 0 because 0 would be mapped to 8. Those would be the same point. So it could be 0. What would make it not a function? -3, 3, or 8. So I hope you understand that a function is when each input has only one output. The next thing that I want you to do is the functions work, the function practice problems.